Okay, so before I continue, I'd like to talk about the print and the print ln print line. I wrote an example over here in this program. So it's called print ln example. Here's my main, and I basically have created 7 different variables here, and I've got a name, an address, a city, state, zip, so on and so forth. So what I'm doing is I'm not asking for anything from the user, so I go ahead and create this file called print line example, print ln example, and then I basically say output. So here's my print writer. This is my print writer class. It's part of the java.io, and I create a output file, and it's instantiated from a print writer, and here's my file name. So I say output file.println. Now, very important what the ln does. It goes ahead and prints the phrase example print ln. Now, since we have a print ln, what that does is it goes ahead and prints the line and then automatically drops down to the next line, so the next time we print, it's sitting at the very next line. In this case, it goes ahead and says print ln name, so it goes ahead and prints name. Drops to the next line since it's a print ln. So it does that for each one of those. Then it says print ln, and it's got a space in there, so it's just going to basically print a space, drop down a line. And then it says print ln example print, P-R-I-N-T, no ln. So it prints example print, drops down a line, so it's sitting at the next line. This time I say print. Notice it doesn't say print ln. And I'm saying name and concatenate a space behind name. Because here's when we do a print, it prints that line and it sits right there. It doesn't go anywhere. It doesn't drop down a line. It's sitting right there at the end of that text. So I put a space behind it. So it basically prints name, space. Now it's sitting right there. And I print address and a space. I print city and a space. State, space, zip, space, and finally ID number and space. Notice when I say ID number, I do make that a print ln. The reason I do that is so in case I do any printing after this, it's already sitting at the next line. You know, so if you do just a print, now what this is going to do is going to print that phrase on one line, and at the end when it prints print ln ID number, it prints ID number and then drops down a line. So if I go ahead and run this, it comes up and says data has been written to the file. So now if I come over here, here's now my print ln example. I double click on it, and there's my example print ln, Joe Smith, boom, boom, boom. So you notice each one of those is on a separate line because of the print ln. And then I've just got example print. So here's my Joe Smith space, then my address space, my city space, IL state space, zip space, and then ID number was print ln. Now if I click right here, yep, you'll notice that my insertion point is sitting on the next line because it did say go to the next line. So now the next time it would print to this file, it would print at the next line. So realize there's a print ln and there's a print. Very, very important to understand how each of those work. On page 337, it talks about the throws statements. Let me just bring that over here in the book. Now, you'll notice that in our code, when we do a public static void main, it's got throws IO exception. What's going on there? Well, what happens there is it allows us to capture an error before, or so it doesn't stop the run of the program. It basically stops and says, hey, I received this error, and allows you as a programmer to capture an error, take care of anything that needs to happen, and then basically continue on. So for example, if a file didn't exist, we could actually capture the error, display the message to the user and say, hey, that file doesn't exist, please type in the correct file name, and let it happen again. So we could actually kind of put it in some type of a loop situation. We're not going to get into that real heavy. This is about all we're going to talk about. But Chapter 11, which we're not going to cover in this class or the next class, but Chapter 11 talks about the throws statement and how we can capture errors and display things to the user to let them fix them. For example, if I'm expecting a string, or I'm sorry, if I'm expecting an integer variable and they type in string data, we can capture the error so it doesn't blow up and display a message back to the user to say, hey, you entered non-integer data, please enter integer data. Okay, so continuing on. Oh, by the way, one more thing about, you'll notice right here, I've got my print ln example.txt. If I wanted to, I could actually type in C:. Now, very important, we cannot use backslashes. If we kind of refer back to a couple of chapters previous, remember we got /n/s, so whenever it sees a backslash, it's expecting some parameter. So we have to use a /. So that's basically the slash that leans to the right. So in this case, I would type C:, users / mark_web / workspace, or however you want. So I can actually type in the big long string path name to put in there. So in another chapter, we can actually capture the path statement of the current path we're in, and we can utilize that as well. But anyways, just realize we can type in the full path name. And again, reading a file. Here's the read demonstration where we basically, again, we're using the keyboard next. We're going to use the console to type things into. And here now I'm talking about a file. Now this is a file class. And I go ahead and create a new object called file, and I'm instantiating it from as a new file class using this parameter file name inside of it. So I go ahead and then say the input file is a new scanner file. So there's my actual file name, and I throw it into the input file class right there, and then I say input file.hasNext. I talked about that earlier. HasNext says, hey, is there a next record? Is there a record after this one? And then I say string friend name.input file.nextLine. And the next line method is covered on page 242. It's used to read a line from a file. So that's basically all that it's doing. It's basically reading a line from a file. So hasNext is a Boolean switch, let it saying, hey, is there a next record? So that's basically all that is doing. So next line is reading the next line available. And again, as we read lines, it reads a line and then basically kind of puts a little switch behind that to let the program know where we're currently at. Think of it like a bookmark. And it reads the next line, sets a bookmark, reads the next line, sets a bookmark. So it always knows where we're at in the process. So if I've got 562 records and I'm at record 252, it knows I'm at record 252 because of my little bookmark. Okay, and that's where the hasNext and the next line come into play. Adding the throws to the headers on page 245. I think I've already covered that. Realize we can trap errors. We can actually do that, and if you want to read more about that, you can look into chapter 11, kind of read up on that. We can read primitives in a file. So for example, here I have the file sum, And here I basically have my numbers.txt file. Since I do not have a path in there, it's going to default to my project folder. In this case is my week 8 underscore chap 4 underscore 5. I'm using my input file from so the scanner is basically going to go ahead and get that. While the input file has next, you'll notice in this case it says input file dot next double. Before we had next line, that's expecting string data. But if I have integer data or numeric type data, doubles, longs, shorts, whatever the case may be, we have to specify that here. Next double, next integer, next so on and so forth. And then I can say sum. So right up here I've got double sum equals 0.0, so I'm initializing it to 0. I can say sum equals sum plus number. I could have also said sum plus equal number. I remember that from last chapter. So and then again, we always make sure we close the file when we're done. Okay. So again, if I were to run this, and it's going to go ahead and read all those, and it comes up and says the sum of the numbers is 41.4. Okay, so if I were to open those files, so here's my numbers, you see it's 0.7. Okay, so if we added those all up together, we would basically come up with 41.7. Okay, so again, when we're reading, we have to tell it what type of data we are reading. Now, I could have read it as a string and then parsed it, but again, that's one extra step. This is also one of the situations where might be the best thing to do, because if I'm expecting a double and there's string data in there, we're going to get an error, and then we have to use a throw. So again, whatever is the best situation, but realize we can go ahead and read with the next, and I can say next integer, next double, next line, so on and so forth, depending on the type of data we have. That's all we have so far. I can only do 15 minutes at a time from a video lecture, so I'm at the end of getting to the end of that. So we're going to continue on with checking to see if a file actually exists when we come back. So we will see you